Well, pre-calculus classes, as always, good morning, good afternoon, or good evening. We'll actually go ahead and continue into Chapter 3 here, 3.3. We're actually going to be a little past the halfway point with this, but we'll talk about properties of logarithms again. Probably going to be some review with what you see here today. So, for all of these properties, we are going to say that both m and n have to be values that are greater than 0. Again, you cannot take the logarithm of 0 or a negative number. So that's why these both have to be positive. So the first one, if you have something like log base b of mn, well, there are going to be some instances where we may need to split things apart. If you need to split apart a logarithm, that becomes log base b of m plus log base b of n. You know, where you've seen something like this, if you think about, x to the 5th times x to the 4th. Well, when you're multiplying with exponents, you add. If you are adding logarithms, you would combine by multiplication. Log base b of m divided by n. Much like with exponents, if you were dividing, you subtract. So again, if you had x to the 9th divided by x to the 3rd, x to the 6th. So these all have some similarities to your properties of exponents. Now, this last property, I've already kind of alluded to it a little bit. I know when we were talking about, I think, the final example in 3.2 with logarithms, where we had a power inside of the logarithm. Well, if you have a power inside of the logarithm, you can move it out to the front as multiplication. This one's a little tougher to really relate to properties of exponents, but again, essentially the one that it is parallel to is if you have x to the 5th to the 4th, where if you have a power to a power, you multiply. Well, here, a logarithm is the inverse of an exponent. So if you have, again, it's kind of like an exponent, it's just the inverse to a power, we move it out front and multiply. So again, it's at least kind of along those lines. All right, for this one, we're going to actually use the properties to expand into separate logarithms. Now, here's the key thing. If you notice, when we expand, both terms have a logarithm. So for this one, log base 10 of 6 times x squared times y to the 3rd. Well, we are actually, because they're all being multiplied, going to expand the multiplication using addition. Now, it's certainly up to you. Log base 10, you are more than welcome to write those bases in. I'm not. One of the reasons why they use this example like that is just so we can review over the fact that you don't have to write those in. Now, there is one last step. When you have these exponents inside, we can move them out to the front. So it's log 6 plus 2 log x plus 3 log y. If you're able to go directly from here to there, that's fine. I just wanted to at least kind of let you see the in-between step there. All right, next one, natural log. Well, now we have division. So to expand division, we are going to subtract. Now for this one, because it ends up being just some random decimal, do not worry about actually plugging in natural log of 8. Now, even though I know it's not as obvious as the one up here, we had 2 exponents we did need to move out to the front. Well, again, going back to the last section, a square root is like a 1/2 power. So we can actually move that exponent, just like the prior example, out to the front. From here, don't worry about trying to split anything else up because that's a quantity with addition. We can't really go any further now with this one. All right, so write the logarithm in terms of natural log 2 and natural log 3. It is once again, or these are, I guess I should say, expanding problems. Basically, what we have to do is rewrite this value in terms of 2 and 3. So, well, to get 6 from 2 and 3, that's just the natural log of 2 times 3. So then this is natural log 2 plus natural log 3 when we expand the multiplication using addition. Once again, do not actually worry about whatever decimal that is. Now this next one, natural log of 3/8. Well, to start out with the division, we'll expand it using subtraction. Now, this one's maybe not as obvious. You know, how are we going to get 8 from 2 and 3? Well, the way we're going to do that is 8 is 2 to the third. And so then we can, again, move that exponent out front. So natural log 3 minus 3, natural logs 2. All right, so there are some expanding examples. We can also use these properties to condense. If you are condensing, and one of the reasons why I've kind of shown these stepwise is the first thing that we need to do with these, move our exponents back inside. So this is log x to the 1/2 plus log x plus 2 to the 4th. Then to condense the addition, and that should be log, not natural log, log, and then I am going to go ahead, rewrite that as the square root of x times x plus 2 to the 4th, and then I'll just put the grouping symbol there just to make sure it's obvious everything is in there. Don't worry about expanding x plus 2 to the 4th. I mean, that's going to get ugly if you try. Just leave it like that. So, condensing, move your powers in first, then worry about addition or subtraction. All right, for B, 2 natural log x plus 5 minus natural log 8. Again, we do need to move that power in. Here, yeah, this would be pretty easy to expand. I mean, you can if you want. Again, we're not going to be real worried about you doing that. The key thing from here is now to condense the subtraction. We make it division. Now, the other thing that, for whatever reason, it's a more common mistake we see with the division. Notice I'm only using 1 overall natural log. There is a tendency we see natural log on the top and bottom. You don't need to do that. This is the entire expression there. This next one, there's actually a lot of different ways you could go about this one. I mean, certainly one option, if you wanted to distribute that is one way about this. From here, now, we can move our powers in. So the natural log, square root x plus 1. Here I am going to go ahead and just do that all in one step. Nothing's going to happen here. And then x to the 6th. Well, we have 2 sets of addition. Kind of like example 1a, we're just going to have all 3 things combined together as one single quantity. So from here, I'll go ahead and put the x to the 6th out front, x minus 1, and then x plus 1. And again, especially with a long chain like that. Now, for this one, it's kind of up to you here if you would want to go ahead and distribute there. I actually think I kind of like doing that, but again, if you stopped here, that'd be fine. If you did go ahead and go one step further with that, certainly fine as well. So there are some condensing problems. And then the last thing, change of base. Now, I know that the other day with 3.2, we looked at some logarithms that you could actually figure out in your head. If you were to try to do example 4 here, log base 4 at 27. Let's say we did go ahead and set this equal to x, 4 to the x equals 27. Well, 4 to the first is 4, 4 to the second is 16, 4 to the third is 64. Well, there's no nice, neat, obvious value there. The other thing we looked at is, can you rewrite things as powers of other bases? Well, yes, you could here. You could make this 2 squared and 3 to the third, but since those are different bases, those don't really help us. So we're stuck, and so this is where you use one of two things with change of base. There are 2 logarithms your calculator will do. You can either take log 27 over log 4, or natural log 27 over natural log 4. Doesn't matter which one you use. I'll admit I tend to use regular log more unless I have e involved, but if I take log 27 divided by log 4, 2.377. If I take natural log 27. Now, the one thing you do also need to be careful about is, depending on, what your calculator does, make sure that you do, if it opens a parenthesis there, close it before you divide. And I get the exact same thing. So you can see either way we get 2.377. All right. Well, from here, the only other thing that, I know we talked the other day about, if you were to try to graph, if you were graphing this without a calculator, we would take 5 to the y equals x, set up a table. Well, you do have an option with your graphing calculator here. Now, I know that some of the newer ones may actually even allow you to graph different bases. If you have an older model like this one, well, what you would have to do, log x divided by log 5, and then you could graph log base 5 of x. So let's see here, log x. Again, close your parentheses, divided by log 5. And there it is. If we even just kind of reset our window, just you can even see right there is that 0.51. So now the only thing that it does kind of look like it does actually intersect with the axis. Some of the graphing calculators, they can't show that detail that it does continue down there. So that's one other possibility that change of base would offer for you. So with that, we are actually now done with section 3.3. A lot of the sections in chapter 3 are actually just one day, fairly short topic. So that concludes, like I said, 3.3.